All right, welcome back. Part 2 of Lesson 5. We're continuing with Example 2, and we've just discovered using our factor theorem, when we subbed in x equals 1 into our polynomial, we had a remainder of 0. So therefore, if we have x equals 1 and we bring the 1 to the other side, that shows us that x minus 1 is a factor. Okay, so we know then if we go p of x equals, we have x minus 1, and then we're going to have something else. This part we'll get through synthetic division. So we're going to put what x equals here, x equals 1, and then we put our coefficients across the top of our original polynomial. So 1x to the 4, 2x cubed, negative 7x squared, negative 8x, and then positive 12. There we go, and we begin our synthetic division. I'm going to let you guys do that since you know how to do that really well from the last lesson, and then we'll take a look at how to go further with this. Okay, so pause your video. Okay, so hopefully the remainder was 0 again when you did it this way. And then we have to write these numbers at the bottom as a quotient. We started with x to the 4. We divided by x minus 1. So therefore we should be ending up dropping 1 degree. This should now be x cubed. So 1x cubed, 3x squared, negative 4x, and then minus 12. Okay, now you'll notice what's still inside the brackets here, unfortunately, is a cubic polynomial, which means, oh wait, haha, guess what? We're going to do factor by grouping. How do you recognize this? Because do we really want to do synthetic division again if we don't have to, right? If you look, our coefficients here, 1 to 3, 4 to 12, if you can multiply 1 times 3 is 3, and do the same thing with these last two, negative 4 times 3 is negative 12, guess what? You could factor that using factor by grouping. So we're going to do that. Okay, this x minus 1 keeps going along for the ride, and we're going to group, let me just erase this part here. We're going to group the first two terms, group the second two terms. I'm going to put big square brackets, okay? Out of the first two terms, we factor out x squared, leaving x plus 3. Out of the second two terms, we factor out negative 4, leaving x plus 3. All right, now here we have two terms, because these things are multiplied together, with a common factor of x plus 3. So now we can factor out x plus 3, and we would be left with this, when we divide it out of this term, x squared, and out of this term, negative 4. And there we go. Okay, so that helped a little bit. We didn't have to do synthetic again. And notice we have a squared somewhere. Can we go any further? Yes, look at the squared. X squared minus 4. That looks familiar, doesn't it? Two terms, opposite sign, or the minus sign in between, that's a difference of squares. So x times x gives us x squared, and 4, 2 and 2, opposite signs. There we go, factoring our difference of squares. Okay, so have we answered the question? Express the polynomial in factored form. There we go, it's all nicely factored. Now, second part, state the zeros of the polynomial. Okay, so setting each of these factors to 0, you would write down what those values are, and then state the roots of the equation. Okay, so you guys go ahead and write those down, very similar to what we did before in a previous example, and then we'll check back and see if we have the same answer. So pause your video, please. All right, so just like on a previous example, setting each of these factors to 0, we would get x equals 1, x equals negative 3. I'm just going to make sure you know how to do that. X minus 1 equals 0. Add 1 to the other side. There we go. Same thing here. X plus 3 equals 0. Subtract 3 to the other side. Okay. And there we go. Our zeros. And as you recall from our initial part of the lesson, zeros of a polynomial function are the same as the roots of the equation. So same answer for part D. Okay. Let's look at example number 3. Consider the polynomial function p of x equals, okay, so cubic polynomial function. Find the zeros of p of x to the nearest hundredth using a graphing calculator. Okay, so we're going to do that. So we'll need to pause the video, bring the graphing calculator up, and I'll walk through finding one of those with you, and then you guys can find the other two. Okay, so let's put that equation in y1. Okay, so x cubed minus 3x squared minus 3x plus 1. Okay, so everything's entered in there correctly. We've got minus signs, not negative signs, right? There's the minus here versus the negative here. Okay. All right, so I think we're still on Zoom standard from our last example, so we should just be able to hit graph, see what we have. Okay. So any of those, oh, we want to find the zeros to the nearest hundredth anyways, doesn't matter. Okay, so second, calc. This is how we're going to find, how did that not work? Second, calc. Okay, and we want to find the zeros. So look at that, number 2. Okay, but my just selected something different. So number 2, bum, bum, bum. Okay, so when it asks for left bound, okay, let's say we're trying to find this far left x-intercept here. We want to make sure we cursor to the left with that little flashing thing to make sure we are left of it, okay? So hit enter on that. Then it says right bound. Where is right bound? Okay, so we go to the right. Okay, so now we are to the right of that. Okay, so you hit enter. Okay, and then it says guess. Well, as long as you're somewhere between these two arrows when you hit guess, it will find it. Okay, if you want to move down to where you think it is, that's fine too. Okay, but you're basically telling the calculator, can you please look between these two values to find out our zero? So we hit enter. And we get x equals -1. I thought that one was x equals -1. Okay, so we're going to write that down, okay, and then we're going to find the other two. Just remember when we're finding this middle one, left bound would be above the x-axis, right, because we're left, and right bound in this case would be below the x-axis. Okay, so you guys go ahead and find the other two. Hopefully they go well. I do believe the next two are not going to be pretty, so you have to round them to the nearest hundredth. I'll probably walk through one more of those, I think. Okay, so I'll just help you get that that next one. Okay, so 2 for 0. Left bound, we want to be left of where we think that middle x-intercept is. That should be good. Enter. And then right bound of that next x-intercept. There, good. Enter, and then we just want to hit enter again for guess. All right, yeah, so not a pretty number here. Let's see, to the nearest hundredth, we would round that to 0.27. The 7 causes the 6 to go up to a 7 if you're rounding to the nearest hundredth, which is 2 decimal places. Okay, so I'm going to write that down. You guys go get the other x-intercept, and then we'll see if we have the same answer, okay? So pause your video, please. Okay, so hopefully everyone arrived at the same zero I did, which was 3.73. Okay, now part B says use the integral zero in A. Okay, so there's only one of these zeros which is an integer, and that is -1. Okay, the other ones are rational numbers. Or they could actually be irrational, okay, but they're real numbers. And synthetic division to determine the exact value of the zeros. Okay, so here's what we're going to do. We are going to jump into synthetic division. Okay, so we would put -1 here, our coefficients across the top. Okay, and then we're going to use synthetic division to get our quadratic quotient. Okay, why don't you guys go ahead and finish that up, do the synthetic division, and then turn it back into x's, and we'll talk about the next step. So pause your video, please. Okay, so we should have arrived at this quotient, x squared minus 4x plus 1. We have a remainder of 0. That's a good sign. Now, just rewriting our divisor back in factored form. So this was x equals -1. So to turn it back into the factor, add that 1 to the other side, x plus 1. And then we have x squared minus 4x plus 1. All right, so that was turning each of these back into x's. Okay, so rewriting this. Now, we want to try and factor what's still inside the brackets there because we see an x squared. Likely it can be factored. Maybe, let's see, adds to 1 or multiplies to 1, adds to -4. Yeah, I don't think so. The only two things that multiply to 1 are 1 and 1, so that's not going to add to -4. So do you remember from 20-1, what do you do if you can't factor quadratic? What's your other alternative? Okay, you can use the quadratic formula. So we're going to be using the quadratic formula, x equals negative b plus or minus the root of b squared minus 4ac all over 2a. And our a is our coefficient in front of x squared, our b is our coefficient in front of x, and our c is our constant term, positive 1. So let's replace everything in there. So negative, and then b is negative 4. So for now, use brackets to sub that in. Okay, and make sure you use brackets here because you're squaring a negative. That's important to have brackets so that the negative gets squared as well. Okay, so we're replacing a and c, and then on the bottom, 2 times a, which is 2 times 1. Okay, don't try and simplify that at first. Just sub everything in. Okay, now, do not put this in the calculator. You know why? When they say exact value, and you know that from up above we got some decimals, okay, the calculator is not going to help you on that. The root of like 5, you can't put that in the calculator to get an exact value. It's a non-terminating, non-repeating decimal. So you're going to have to round it at some point, therefore no longer exact. So keep things as radicals here when they say exact value. So negative, negative, so positive 4 plus or minus. Simplify everything that's under the root. So negative 4 squared is going to be 16, positive 16. Minus 4 times 1 times 1, so minus 4. 16 minus 4 is 12. All over top of 2 times 1, which is 2. Okay, now exact value, but it needs to be simplified, so root 12. Okay, remember simplifying radicals? Okay, break root 12 down into a perfect square that multiplies to 12, and whatever else would give that. So a perfect square number is like 1 squared 1, 2 squared 4, 3 squared 9. So 4 goes into 12, root 4 times root 3. 4 times 3 is 12. The root of 4 is 2, and then we have root 3 still. So 2 root 3. Okay, now notice this term and this term and this term all have a common factor of 2. So guess what we're going to do here? We're going to factor 2 out of each of those terms. 2 divided by 2 is 1, and 4 divided by 2 is 2, and 2 divided by 2 is 1. So our final answer is going to be 2 plus or minus root 3. And there we go. Little bit of radical stuff, little bit of quadratic formula from 20-1. And those should be our exact values. And don't forget about this one. Okay, the exact values of our, I'll just add that one on the end, of our polynomial function. And if you put these, if you go 2 plus root 3 in your calculator, I bet you anything it's 3.73. And 2 minus root 3 in your calculator, it's probably 0.27. Okay, just to confirm that those are equal. All right, now we would be finished right now, but there's one thing I want to mention from the previous example, just popped in my head. When we're looking at our integral zero theorem, okay, we were writing down all the potential zeros from this list up here. You'll notice that our actual zeros, these ones here, are all part of that set, right? 1, that was there, negative 3, that was there, 2, and negative 2. Okay, just confirming that, yes, we did it correctly. If you'd gotten a number here like 8 and it wasn't in this list, something would be wrong. Okay, just checking in on you for that one. All right, good job, everyone. You should be able to do lesson 5 now and develop some more skills in polynomials. All righty, good job. See you next time.